In this part, we're going to focus on dividing radical expression. So when it comes to dividing radical expression, we're usually going to have it in the form of a fraction, as you can see in the first example, 3 over the square root of 7. When we're working with division of radical expression, we're going to rationalize the denominator. So when you hear the term rationalize the denominator, it means that we're going to change this form into another fraction where we do not have a radical in the denominator. So again, with division of radical expression, when you have it in the form of a fraction, our final answer cannot have a radical in the denominator. So I repeat, when it's given in a fraction, the denominator cannot have a radical in its final answer. So we're going to be rationalizing the denominator. So I'm going to show you the work on how to rationalize the denominator into a form where there is no radicals within the denominator. Now in this example, what you need to do to start off by rationalizing the denominator is you're going to multiply the numerator and denominator by 1. So let me show you what I mean by that. So if you multiply by 1, then it will be the same thing, 3 over the square root of 7. Now, it still has a radical in the denominator, but I'm introducing the concept of 1. So, we still going to have the same fraction, 3 over the square root of 7. But say, instead of 1, we change that 1 into a fraction, 1 over 1. It's still equivalent into 1. And it's still going to be the same thing, 3 over the square root of 7, which is fine. Again, we're just trying to find the equivalent form where the radical is not in the denominator. But now, what happens if I change this fraction into a different fraction? Now, what I mean by different fraction is that if, say, we had 2 over 2, that equals to 1. Or negative 4 over negative 4, that also equals to 1. Say we had m over m equal to 1. Or negative x over negative x also equal to 1. What's in common with all these fractions is that the numerator is the same as the denominator, hence they all equal to 1. So what we're doing right now with the 1 is reconfiguring into a different fraction where the numerator and denominator is the same. So instead of multiplying the example by 1 over 1, we're going to multiply the example by its denominator. So let me write down the example first. Now instead of multiplying the example by 1 over 1, I'm going to multiply by the denominator. So square root of 7 over square root of 7. So when I do 7 times 7, I'm going to have 49 inside the square root. From there, my numerator still stays the same, but in the denominator, 49 is a perfect square number, so that means that you can do the square root of it. So the square root of 49 is just 7. And there's nothing you can do to simplify the fraction, which is okay. So what we want to do is just box it because that's our final answer. But I do recommend that if you can simplify the fraction, you can only simplify the numbers that's outside the radical. So you would only focus on a 3 and a 7 if you are trying to simplify. Never mess with the number inside the square root unless you can also simplify the square root. But this is the process on rationalize the denominator, so that way we get a new fraction in a different form, just no radical in the denominator. So this fraction is equivalent to this example. It's just we rationalize the denominator where it's in a new form with no radical in the denominator. It's okay to have the radical in the numerator, just not the denominator. In this example, we have 4 square root of 3 over the square root of 6. So we're going to rationalize the denominator. So I'm going to basically multiply top and bottom, the numerator and denominator, by the square root of 6. So when I do that, again, the 4 is going to multiply with the 1 that's outside, the invisible 1. I'm going to have 4 outside the square root. And then what I'm going to do is 3 times 6, that's going to be 18 inside the square root. And then on the bottom, it's going to be inside the square root 6 times 6. So that means it's going to be 36 inside the square root. Now I'm not doing the whole work as the last example, because in the last example I was just showing step by step. Here I'm just talking about the process. So this is basically the work you just need to show to me if this was, say, on a quiz or a test. Now next we're going to simplify the square roots. So here inside the numerator, inside the square root of 18, you can simplify and you're going to break it down into square root of 9 times the square root of 2 over. Now square root of 36, it's a perfect square number. That means that you can actually do the square root, which is 6. From there, 4, and here you can actually do the square root of 9, which is 3, and then the square root of 2 stays the same, over 6. Then I'm just going to do 4 times 3, which is 12, and then carry the square root of 2, and then bring the 6 in the denominator. Now you can actually simplify the outside number here. So 12 divided by 6 is 2, and it still has the square root of 2. Again, I did not mess with the number that's inside the square root. I only simplified the number that is outside the square root, which is 12 and 6. So I finished simplifying. This will be my final answer. In this example, we have 3 square root of 3 over 4 square root of 12. Now what's different with this example is that now we have a number that's outside the radical in the denominator. And that's okay. So we're still going to rationalize the denominator. It's just I'm still going to go based on my statement, which is multiply the numerator and denominator by the radical that you see in the denominator. So I'm simply going to multiply numerator and denominator by square root of 12. And not worry about the 4. Now, you can still multiply with the 4. It's just that you're going to multiply with the outside number, and you're just going to have big numbers. Now, if you finish rationalizing the denominator, you should be able to simplify and get the same answer as what I would have once I finish with this example. But again, you can simplify, you can multiply with the 4. You're just going to get bigger numbers, more work. As long as you simplify correctly, it should be the same answer. But here, we're just going to multiply by the radical, which is square root of 12. So when I multiply, we're still going to have 3 outside in the numerator, and then inside the radical, 3 times 12, that's 36. Over, I'm going to have the 4, but now when we do the square root of 12 times square root of 12, so inside is going to be 12 times 12, which is 144. Alright, now I'm going to simplify the square roots. So let's take a look at the numerator. Now in the numerator, we still have the 3, but what we know is that 36 is also a perfect square, so that means you can do the square root of 36, which is 6. Now let's take a look at the denominator. We still have the 4 on the outside. Now the square root of 144, it is a perfect square number, so the square root of 144 is 12. Alright, so I'm just going to multiply my numbers in the numerator and denominator. So 3 times 6 is 18. And then denominator 4 times 12 is 48. So we have 18 over 48. We can actually simplify the fraction. The numerator and denominator are both divisible by 6. So I'm going to simplify by a factor of 6. 18 divided by 6 is 3 in the numerator. And then 48 divided by 6 will be 8 in the denominator. So I finished simplifying my fraction. This will be my final answer. So if you had multiplied the numerator and denominator by 4, again, you would have big numbers and a little bit more work. But if you simplify correctly, then you should get the same answer as I did, which is 3 over 8. But as I stated, even if you have a number in front of the radical when it's multiplying, then simply multiply the numerator and denominator by the radical you see in the example in the problem. In this case, the square root of 12. And then you're just going to continue simplifying the radical. Except in this example, both the radical and the numerator and denominator were perfect square. So that worked out well. But if it didn't, it's just going to be the same as the last two examples. You're just going to have a radical in the numerator. So just make sure to double check, simplify correctly, and then you should be good.